Hello everyone, very good evening to all and welcome to the Gate Wallah channel. Here in this session, as in the last class I have explained that context free languages we have started and we have seen the context free grammars. Then we are moving to the push down automata. Do you know, for the exam point of view, push down automata is not much important, but without knowing the push down automata, maybe it would be not easy to understand the context free languages. So you should be constructing the push down automata. So this session and the next session will be focusing on what is push down automata. Yes, very good evening to Seema, Tanuj and Kashyap. Yeah, good evening to all. How are you doing? How is your preparation going on? All is well? Yeah, nice. Okay, let me tell you one more thing. As you are preparing for the gate seriously, I saw you that coming from the beginning, and keep keep some points very important with you, like never deviate from your preparation when you have the primary target for cracking the gate exam, right? You have plenty of exams to crack, and if we are really seriously preparing for any competitive exam, so give much time and focus more on understanding the concepts. Okay, so my aim in every class is to give you the understanding of the basics, right? Then we'll go for the problems. We never start directly problems and we never practice directly gate questions. We always do one thing, that we go with the basics. What is definition and how you understand the definition, then how do you apply the definition. So these things we do in a sequence, right? The same way, while you learn, you make one habit that every concept that you read or that you apply, you must go in a particular sequence. Okay, great. So let's go for the push down automata. In this push down automata, we will see what is a PDA and how many ways this can be designed. Good evening, Prabhakar. How many ways you can design, and that means how many ways you can accept the string with the help of PDA. Then how do you construct, what approach we use, then what is the difference between DPDA and NPDA, then some of the important points, and we'll see practice questions. But all may not be done today. Some things, some basics we'll do today, and in the next session, that is upcoming session, we will see a more on construction oriented, right? Let's start with the basics of the push down automata. So you are aware of the finite automata, right? So what is a finite automata? If you have seen the finite automata, you have 5 parameters. Do you agree that you have 5 parameters? Of course, this finite automata is 2 types, DFA and NFA, both are equivalent. We know that DFA and NFA both are equivalent. DFA definition is something like, right? Have you remembered the DFA transition? DFA transition is Q cross sigma, that is a domain, and codomain is Q. And NFA along with epsilon transitions, the Q cross sigma union epsilon, that maps to 2 power Q elements. Correct? So this is about a DFA and NFA. You have remembered, I hope, that parameters. Q is a set of states, sigma is the input alphabet, delta is a transition function, and Q naught is the initial state, F is a set of final states. Now, how this is different from PDA, or how PDA is different from finite automata? So if you want to know about a PDA, push down automata, so look at that. The PDA is having 7 parameters. How many parameters? You have 7 parameters. You have 7 parameters, and this is either bottom you can use, or Z naught is, sometimes you may use other symbols also, that's fine, and the gamma. So what are these 7 parameters? And also remember, all parameters are not compulsory. This, especially this parameter and this parameter, you have the choices. Some PDAs, the F is not required. Some PDAs, even bottom of the stack symbol is not required. Okay, so let me help you. What are these parameters? This new parameter gamma is called as stack alphabet. What do you mean by stack alphabet? Stack alphabet is nothing but the set of stack symbols. Like input alphabet is set of input symbols, and stack alphabet is, because you are going to use a stack here additional to the finite control, you are going to use a stack additionally. So these two parameters are going to represent the stack related, okay, the stack related parameters. So addition, this is like a finite automata, and this is going to be stack parameters. So the PDA is actually looks like the finite automata plus this stack. So if you have a stack additional to the finite automata, then it can behave or it can understand the context free languages. Yeah, Seema. Oh, finite versus regular. What is the difference? Finite has a finite language has finite number of strings, but regular may have the finite number of strings or may have the infinite number of strings. Example, A star. A star is not a finite language. A star is going to generate infinite language, it is regular. Regular language means you will have a DFA, definitely, and every DFA represents regular. But finite language, you can design a DFA, you can design a finite automata, but finite automata need not represent finite, remember, because finite automata can also represent infinite language. We have seen in identifying languages, right? Yeah. The motivation is, if you look at the real-time applications, the most of the applications are built with the help of this stack. Example, if you have the, call list, the recent, the call you will see up. And if you see the messages in your phone or mobile, right? So the recent message you will see up. So it's last in first out manners. When you browse the web pages, the last in first out. The reason behind the stack is the most of the applications which are categorized based on the stack, not based on the queue, right? Remember, but if you really wanted queue, you can use the two stacks, you can implement the queue. That is additional anyhow. But most of the real-time applications are categorized with the help of the stack. That's why in the TOC we are using mainly the first most important data structure is the stack. Anyhow, this bottom symbol is initially top of the stack. That is a bottom symbol, you can say bottom of the stack symbol, but it is initial top of the stack symbol. And you know these 5 parameters, but here the PDA is also called as non-deterministic PDA, NPDA or NDPDA. But what is DPDA? DPDA and PDA both are not equal power. So if you are, don't say PDA is 2 types. Here, like for example, you can say 2 types, DFA and NFA, both are equivalent. But here the PDA is by default called as non-deterministic PDA, and we have 2 types of machines with the help of the stack that you can design. One is deterministic PDA, same parameters we use, but the delta that is defined as Q cross the sigma cross the gamma that maps to Q cross gamma star. And whereas PDA also called as, or you can call it as NPDA, both are same here. Here Q cross sigma union epsilon and gamma. If you really want advanced PDA, you can also use star here, Q cross gamma star. So here a few important points. Some textbooks may or may not use this one, but if you want to keep this star, it's fine, or if you don't want, it's also fine. You can have 2 different definitions for PDA if you really want it. Yeah. Do not assume why the stack is used. Okay, it is not what you said. You are not classified the Chomsky hierarchy, right? Based on the Chomsky hierarchy, we have this theory of computation for understanding different problems in the world, right? Okay, so Chomsky hierarchy, the second class that we are studying here is a context-free languages type 2 class. Type 3 we have completed regular languages class. For that you do not need any data structure except one byte you require to understand a string. To understand a string, just we are going to read a symbol by symbol. That means each symbol you can keep in character and you can understand. But here to understand the context-free languages, you may require sometimes stack. That's why you need a stack additional to your program or your finite control. Okay, so PDA and parameter, when you compare, there is additional parameter that comes as a gamma. So the gamma is going to represent set of stack symbols. Okay, let's try to understand more in detail. When you look at the finite automata, right, you might understood that you have a input tape, and you have the head. Let's say it is called as read pointer or read head. Okay, head that is going to read the symbols only, and you move only one direction. Let's say you have the symbols like AA, BB, and you have the finite control that whatever the states and transitions are there, but finite number of states and transitions, that's definite. And along with this, additionally you have something called as stack, and stack is unbounded. You cannot put a limit on the stack, how many symbols that you use. That input will decide how many symbols we are going to push, and by default initially there is a bottom symbol is there, and this finite controller is going to use the stack. It may use operations like push or pop or nothing, no operation, nothing, no operation. Okay, no operation, that's fine. So this finite control can use a stack to perform two operations, either push or pop. Sometimes if it is not required any operation, you may not use a stack. If right, how do you use this stack is very important for this push down automata. Okay, all is well so far. Now along with the finite automata, you have additionally stack. So some people may define that PDA is equivalent to the finite automata along with a stack. The stack is here unbounded, of course equivalent. Okay, equivalent. So you need to design the finite automata along with the stack so that it should work like a finite PDA. It should work like a PDA. Now what is the language accepted by PDA? I am talking about a PDA, right? PDA is by default it is non-deterministic. By default it is non-deterministic machine. Okay, and that is why it accepts or it represents which language? Context free language. We don't say DCFL because this machine is more powerful to represent even other than the DCFLs. It represents context free language, CFL. CFL also called as non-deterministic CFL also called as non-deterministic context free language, remember that. Now when you compare the DPDA and PDA, DPDA is less powerful than PDA. Why we say that DPDA is less powerful than PDA? Because what DPDA represents are DCFLs, what PDA represents context free languages. When you collect all the DCFLs in the world over any sigma, they are going to be inside strictly subset all the CFLs. If you put in a set, then you have a set of CFLs is a superset of set of DCFLs. This is the reason if you have the DPDAs, they can represent DCFLs. If you have the PDAs, they can represent CFLs. That's why PDA is more powerful. PDA is more powerful than DPDA. So this kind of questions asked so many times in the exam. Okay, now we'll look into how these machines can be designed. Now don't ask, sir, why DPDA is designed in this fashion. Really we are not aware right now, we cannot understand right now except following what PDA and what is DPDA, right? We have not designed DPDA, PDA, we have not understood how to represent a language. Just we are talking about PDA and DPDA basics. Now when you look at the DPDA and PDA, so we have 2 points. That is, if we are using PDA, the PDA can accept a language or can accept the strings of a language in 3 ways. PDA you can represent 3 ways. Of course, all are equivalent only. Remember, all are equivalent. One is acceptance using final state. You can accept the strings with the help of final state. Like finite automata, you know what is the final state, non-final, right? So if you want to accept a string, you should halt at final. You can use the same concept for the PDA too. You can use the same concept for the PDA too. Okay. Next, another kind of push down automata is you can accept using empty stack. Empty stack, that means without having final state also you can accept a string. This is a very important. People confuse here. So far they have understood the strings by going to the final or by going to the non-final, but in the second mechanism there is only one state. There is no such final non-final concept, only states, and you should not call final, you should not call non-final, because we don't define them in the empty stack mechanism. Okay, to accept the string you should have the empty stack at the end, so that we will see it slowly. Now another one, you can use both if you really want it. You can use final state using both mechanisms, like using both final state and empty stack. These are the three mechanisms, and which may take time to understand. I'm very sorry, which may take time to understand. Okay. But when it comes to DPDA, all are not equivalent. DPDA is mainly two types, and these two are equivalent. What are they? You can use a final state mechanism, acceptance using a final state mainly. This is the main method that we use, but really somebody want it by restricting, you can also use together acceptance using both final state and empty stack. Then what is missing here? If you are using only empty stack, then actually that kind of machine may not be equivalent to DPDA. So the another kind of DPDA is there, that's not the type of DPDA. That's maybe you use the concept of DPDA, but that's not going to be equivalent DPDA. So now there is another machine that I am just saying that DPDA acceptance using empty stack. This mechanism is not powerful like a DPDA. It's a less powerful than DPDA. What is DPDA? DPDA you can use either one of this technique, and when you use empty stack mechanism, actually that's not equivalent to DPDA. It is less powerful than DPDA. Even there is no relation with the finite automata at all. Some of the regular languages also you cannot represent with the help of empty stack if the DPDA using the mechanism. So remember that if any DPDA looks like a DPDA, but you don't call DPDA. If any DPDA that using empty stack mechanism, even that's not called as a DPDA, right? But it comes under the same DPDAs, but it's not equivalent to DPDA. It's not equivalent to DPDA. Okay, to understand this, you need to do some kind of exploring the concepts. And maybe you will study in master level, but I feel that in undergraduate level these concepts are not much important. But if you have time, you should learn all these concepts. Okay, and mainly we'll focus on using final state, and once you understand using final state, later you can compare other things. But without knowing any of these concepts, if you are trying to learn all of them simultaneously, we may not learn very quickly. So if you want to learn quickly, so first focus on acceptance using final state. Once you understand the concept, then move slowly to other mechanisms. Okay, there are three mechanisms in PDA, all are equivalent, and there are two mechanisms in DPDA, they are equivalent, but there is other mechanism which is not equivalent to DPDA. In fact, it is less powerful than DPDA. Okay, so these are the theoretical points which may be asked directly in the exam, so you can relate it. Now let's come to the point that if anybody is going to ask about the languages, okay, it was one of the gate PYQ. L1 is nothing but the set of all languages. It's not one language, remember that, set of all languages accepted by PDA, that's one. And L2, set of all languages accepted by PDA, but mentioning sub mechanism name using final state. Okay, just I want to relate what is the relation between L1 and L2. L3 is equal to set of all languages accepted by PDA using empty stack. Can you relate them? Can you relate them? Okay, so L4 is both. Let's say this is fs, this is empty stack. So both fs and empty stack es. Now L5 set of all CFLs over the same sigma that we are talking about. Now what is the relationship between all of them? Anybody can answer this? I'm waiting for your answer here. Can you relate all these 5 languages? What are they? What is the relationship? Come on guys. Exactly. It's all are same. You know, this is also set of all CFLs. Even this is also set of all CFLs. That means anybody want to relate this, right? So you should say L1, L2, L3, L4, L5. There is no difference. All will give you the same class. The class name is set of all CFLs. You can represent other way the same name. So correct. They are all equal. That means whether I use this word or this word, it's going to be the same meaning. Set of all CFLs is same as set of all languages accepted by PDA is same as you can use any name L2, L3, L4. Okay, that's a good point. So out of them, this was the this L2, L3 was the PYQ, gate PYQ. They've asked this L2 and L3, and they asked what is the relationship between this L2 and L3. So you should say L2 equal to L3. Okay, but in case if they ask set of all DCFLs is given in one of the, let's say L6 is set of all DCFLs, then that set of all DCFLs, L6 is a subset of them. Okay, so if you want to relate with the DCFLs, then that will be subset of these languages. Okay, anyhow, that you need to understand that. Let me write other points, a few points, like L1 is nothing but, let's say, set of all DCFLs. L2 is, let's say, set of all, what do you say, languages accepted by DPDA. L3 is a set of all languages accepted by DPDA using final state f.s. Okay, L4 you have same but using empty stack. L5 just basics, right? We are not learning anything like construction that we can do in the next class. L6 just to understand any relationship with the regulars, set of, let's say, all regular languages. So now can you relate this classes? Okay, it's a very interesting relation is that L1, L2, L3 and L5, they are same. What are they same? L1, L2, L3 and L5, they are same. Now the problem is that L4 and L6, how do you relate? There is no relationship between L4 and L6, but both are their subset of this. Now if you look at L4 is a subset of this one and L6 is also subset of this one, but L4 and L6 has no relation. Do not say L4 is inside L6 or L6 is inside L4. So there is no relation between L4 and L6. So very important, but I think I feel that this may not be important for GATE exam. In case if they really ask, then keep this point with you, that empty stack, only empty stack mechanism has no relationship with the regular languages. That's why this L4 and L6 you cannot relate, but L4 is inside L5 and L6 is also subset of L5. Okay, so these are the main important points. Now first question is, now how the PDA can accept a string? Let's say you are using the final state mechanism, how the PDA can accept the string? I told you that we mainly focus on using final state mechanism first, not anything else. Okay, using final state mechanism. How this PDA can be defined to accept a string. You are aware of that DFA, right? How DFA can accept a string? Same way, suppose this PDA is accepting some language. Okay, let's say language name is L. L is a language here that you can call context free language. If you give any string, if you give any input string W over any sigma, then how this PDA can behave? PDA by default it is non-deterministic, right? PDA by default it is a non-deterministic. Then if PDA is by default non-deterministic, what do you mean by non-deterministic finite automata? The string is valid, it has at least one path that halts at final. The same way PDA is going to define using non-deterministic mechanism, that is if valid string, that is if W belongs to L, at least one path exists, that halts at final state. That means valid string definitely it should halt at final, no doubt, but at least one path exists that halts at final. If the string is invalid, you can say that a halts at non-final using 0 or more paths, that's fine, but every path should halt at non-final if there are paths. If the string is invalid, it should halt at only non-final. If there is no path, still it is fine. So this is the definition of the PDA. And now using this mechanism, we are going to construct the PDA. Okay, now let me relate DPDA. So what is the DPDA mechanism? If you are using final state mechanism, use final state only. You will always use final state, no doubt about it. If W belongs to L, exactly one path exists, not at least, you can't say at least one path, at least exactly one path exists that halts at final. And slightly we change the definition, but it is same as like DFA. What is, if the string is invalid, in DFA we say exactly one path that halts at non-final. It's the same as, instead of writing exactly one path, you can also say another way, exactly one path if you really don't want, or no path. So exactly one path or no path at all that halts at non-final. If you have a path, that should be exactly one. If there is no path, you can always go to dead state and you can stay there. So no path you can always convert to exactly one path. Why do you want no path now? Because covering every combination will take time in the PDA and DPDA. Don't respond means no need to design or no need to configure it for invalid strings. Invalid strings you no need to have, because you are going to design or somebody else will design. While designing PDA, you no need to have the configuration, or you don't need to have the transitions for invalid combinations. Okay, exactly one path that halts at non-final. If you don't have a path, it's still fine. Either one path that halts at non-final or no path exists, that is also fine. So you can design either way. It's same as exactly one path halts at non-final. Instead of writing this, we are making a new way to design. If I am not having a path means you will be having exactly one path that goes dead state. You can always convert no path to one path. That's why in DFA we are always designing exactly one path, because number of states are important there. Here number of states we don't care. That's why if you are not having a path, that means you assume exactly one path that goes to dead state. Okay, so for any string, if you don't find a path, assume that it is going to dead state, and no path you can always assume you have a one path. Okay, so this is a very important point. The no path is same as one path. No path is same as one path that halts at non-final. Okay, so now we'll just see how to understand this machine. Okay, I'm just talking about a very simple machine's understanding. Okay, first example, if anybody designing, let's say I'm just designing it, what is the meaning of this one? Okay, just A came and Z naught, and you are keeping Z naught, and going to the final. What is the meaning of this motion? Okay, there are only two states and just looks like a finite automata, A, right? So in finite automata, this represent what? This infinite automata we do this way, in PDA we do this way. What is the meaning of infinite automata? What is the language here? Language is accepted simply A. In NFA, in non-deterministic motion, this means A. But can you tell me what is the language accepted by this? What is the meaning of this? It's not the popping A. It is earlier Z0 was there, now also Z0 is there, and you do nothing on the stack, but you are reading A. So many meanings are there. You are reading A, here also reading A, but you don't have a stack, you can't talk about the stack. Here initially Z0 only there, now also Z0 only there. So what is, how do you read it? You are reading input A and you are looking at the Z0 and you are keeping the same Z0. Remember that you are keeping the same Z0, you are not changing anything to the Z0. That means nothing happened on the stack, but you read A and you are going to the final state. That means A is accepted, right? That means A only accepted. There is no difference between these two motions. These two motions are equivalent, but one is the finite automata, other is PDA. Why they are equivalent? Because they are accepting same language. But both are not same motions, but both are accepting same language. These two are equivalent but not same. Only they are accepting, representing same language, but these two are different motions, but they are equivalent. Okay? No, after A, don't say all strings starting with A, Raviteja, because see that after A you can't accept anything. There is no transition from this final state, right? There is no transition from this final state. If you after A, if one more A comes, do you have any path here? There is no path, means it not accepting. When there is no path, it means it is going to dead state. And remember that after A, one more A comes. First A you will go there, and from here if A comes, do you have any transition? No, right? From here if there is any second A is coming, let's say 2A you want to read, 1A you go there, from here A there is no path, means it is not accepting, right? So remember that it's just accepting only one string, that is to A, that is single symbol, that is A. Okay, so I think first example you just got a clarity. Let's go for the second example. Let's go for the second example. Okay. Infinite automata, we used to do something like A, and let's say this is a final state, right? Okay, this means what? Okay, I'm going to design some other way. A, if you have epsilon, and what is the language accepted by this motion? What is the language accepted by this motion? Just think about it. I am coming to that point. A, Z0, and epsilon, Z0, and what is the language accepted by the above? A followed by epsilon. That means first epsilon you can accept, single A you can accept, double A you can accept. This means A star. It represents A star, any number of A's. Now what about this? And understand the same way here, if you want to accept epsilon, and this is not a final, but you have epsilon transition, that too initially Z0 is there. So Z0 slash Z0 means you are looking at the Z0 and you are keeping the same Z0, means nothing happened on the stack, so you are accepting epsilon. If you want to accept 1A, then first you read A and you did not change any stack configuration, and A followed by epsilon is again A, and double A followed by epsilon. So this has the same they both motions represent same language again, but understanding is very important how you accept the string here. Maybe it is very easy for you because you are able to realize, you are able to compare both, but if I ask only this, now realizing might take time. That is a very important how PDA you compare with the finite automata, but every PDA you cannot compare with the finite automata. For beginners, how to understand the PDA, this is the best way to understand how PDA we have to realize, and they're not exactly same as finite automata, no doubt, because the way you design PDA is different from finite automata. Here there is no stack, so you will never think about the stack, but here every transition that you read, you need to focus on what is there in the stack. Am I pushing? Am I popping? Am I doing any operation on the stack? That's a very important. Here I am not doing anything on the stack. I can read any number of A's. Stack is always there, Z0, but here same at the end of this is called as the end of the input. If you come in the middle, right, you don't have a transition here, that means this has to be end. Here also same situation. If I want to read 10 years, the 10 years you have to take this one only. You should never go in the middle of the reading, you should not go to here, right? Okay, so both are accepting A star. Now let's move to the third example. And now I'm waiting for your answer. I'm waiting for your answer. Okay, I'm waiting for your answer. Just focus on this. A, okay. This is finite automata. Now PDA. I'm waiting for your answer, okay. So this is the first time you are going to face it. But I want your answer. What is the language represented by this one and this one? And no doubt this one you can answer easily, A star, okay. This is not a problem. But what is the language accepted by this PDA? I'll give you time. Let's see who will be answering this language. What is the language accepted by this PDA? Very interesting question. This is what? Where we lack. No, Seema, no, Tanuj. That means you are not able to introduce a stack into your brain. So far you are not having the stack and still your brain is thinking without stack only. You are not looking at the stack, you are not touching the stack, you are not taking the consideration of the stack. Then you cannot understand this motion. Unless you keep the stack, you track the stack, you cannot understand. It's not about the empty, it's about the final state, Tanuj. It's not about the empty at all. This is acceptance using final state. I am not worried about empty stack mechanism. I kept the double circle, right? Double circle is about final state mechanism, okay? And this is about final state mechanism. Anybody can answer what is the language accepted by this, okay? And here you are not worried about how you accept the string. Have you understood at least one string? You should never visualize like a DFA or NFA. This is not that's what I told in the previous example. Finite automata and PDA both are completely different, but sometimes both look similar but not always. See that I did not write Z0/Z0. If it is Z0/Z0, if it is Z0/Z0, you might be right, A star. If I give you the machine, this one, definitely your answer could be correct. Your answer is correct, no doubt. L is equal to A star. But I did not give you that. You are not able to look at this. What is the meaning of this? You should understand first. What is the meaning of this? This means push A when A comes. Now, what you need to do, for each input you should understand separately, then only you will get to know what is the language. You can't realize whole language directly without having a good practice. Is that clear? When you studied a data structure and algorithm, have you remembered when the stack comes? It's not that easy. You need to look at what you are pushing, what you are popping, what you are pushing, what you are popping. Otherwise, you cannot understand what happens at the end, what happens right in the middle. The same way, every input you need to understand what's happening. What are the inputs are there in the world? Let's say here only A is talking, right? So just think about what happens on epsilon, A, double A, triple A. What is happening to them? Are you able to realize it? Unless you realize, you can't, right? So are you able to realize this? Are you able to understand this? Let's focus on one by one, okay? So I'm helping you to understand the string by string. So far we were not doing that because they were similar to the machine finite automata. So you did the answer. Now you can't do that way. So epsilon. Now what is the path for epsilon? Let's say this is a Q0 and the path is Q0. And without reading anything, you will alt at Q0, right? That means Q0 is the final. Don't need to read anything. No need to read anything, right? In the previous motion, at least you are reading epsilon, you are going to final. But here, no need to read anything, right? If I'm not reading anything, means you are at Q0 always. In the previous motion, you are not reading anything, means you will be in the Q0 or you can go to here. There are two options. Among these two options, one path is going to final. That's why epsilon is accepted. If I am assuming this is a Q0 and this is a Q1 and there are two paths for epsilon. One halts at Q0, other halts at Q1. Among the two paths, one path halting at final. That's why epsilon is accepted. Now, epsilon is accepted because I have a path to final. Then A, what happens on A? Now look at, you have to read A, then only you can decide. Now look at, initially what is there on the stack? Z0. That's assumption for us because I did not mention Z0 is not there. So by default Z0 is there on the stack, and when A comes, Z0 is there. What is your target? You're going to push A, you're going to push A, and then you will be there in the Q0 only. So from Q0, when A comes, you are going to push it. So this A comes here and you are going to Q0. So is it final or not? Yes. That means A is accepted. Previously epsilon was accepted. So far look at carefully. Epsilon A accepted. Now look at double A. Unless you go for this third string, right, you cannot understand the language. Let's look at double A. What happens on double A? From Q0, when A comes, who is there on the stack? Z0. A comma Z0. Can you push? Yes. This is called as a push operation. So you will push. So A comes. Now you go to Q0. So first A is over. What about second A? What about second A? Q0 A, when A comes, who is the top of the stack? A. Do you have a transition like A comma A slash double A? You don't have it, right? That means A comma A, you don't have a transition, means you cannot read the second A. You don't have a path. A comma A, there is no path here, no transition here. No transition here. That means that is going to be invalid, no path at all. That means double A is not accepted. Double A is not accepted. Look at that, what is happening. The first A you are able to read and second A you are not able to read, because for the second A comma A happens because first A you already pushed. But look at here, there was no stack, first A, second A, third A, the same transition helping, but this one will not help for the second A. Previously, if you have a PDA, something like A comma Z0 slash Z0, that can help you for the second A, because stack is not changed there, Z0 is there always, but here Z0 is not there. After first A, that top of the stack is A. That is the reason the second A is not able to see the Z0, because A was already pushed by the previous A. That makes double A, there is no path here. It means double A is invalid string. And double A, triple A, 4A, everything is invalid here. So what is going to happen? What is the language now? Are you able to understand what's happening here? What is the language now? Are you able to answer it? Just epsilon or A, that's it. So this is the most important point to understand the push down automata. Okay, so this kind of basics are very important. See, we are not going to anywhere, we are not going to design a PDA, but we are just understanding what is a PDA, how the PDA accepts the strings, right? So this is a PDA mechanism, how it accepts the strings with the help of final state. So this kind of understanding we require, and designing might be so easy, but understanding the PDA is more important than designing. So when you come to this chapter, when you come to the PDAs, remember, just take the 50 PDAs that are available in the world and try to understand each PDA. That's enough. If you are able to understand those 50 PDAs, right, that's more than sufficient. You don't need to design a PDA at all, because when you are going to design a PDA, you are going to follow your logic. You're not going to follow other logics, right? For the GATE exam point of view, it's a more important point is understand as many PDAs as possible, but don't worry about how to design a PDA. In the exam, they will never ask to design. Okay, they will give you PDA, they may miss the transition, find out what is the missing transition. Okay, everything will be given most of the time, right? Okay, understanding is more important for this chapter especially. Okay, let's go to the next example. Let's see who will answer it again. Okay, this is something different. Okay, A. Okay, this transition very new for you, maybe. Because I'm designing a PDA, then you should know how you do this. Assume initially Z0 is there on the stack. Okay, this is one kind of gate question which was asked earlier. Assume initially Z0 is there. That will be given in the data. Okay, yeah, can you try this? And I'm saying again, if you cannot understand this transition, and no way that you can find the language. Okay, only the way that you can answer it by understanding each transition first, then put in a sequence what happens. Okay, unless, right? So now focus on understanding the transition. What is the meaning of this? So how many people know what is the meaning of this? It means push A without looking at the stack. Push A without this epsilon means top of the stack. That means don't look at it, and but push A. So don't look at but push A. Push A for input A. That's it. Push A for input A. This is the input, and don't look at the stack. Don't look at stack, and but put A on the stack. Put or push. Put A on stack. Why A? Because here epsilon, here A is there, that means A is coming newly. So push A. This means push A for input A. Doesn't matter what is the top of the stack, we just push A. And what about that epsilon comma epsilon slash epsilon means don't read any input without reading input. Without reading input means reading nothing basically. Without reading input. Without looking at the stack, without looking at top of the stack, and epsilon slash epsilon means, oh, you are not changing anything at all, right? You're not changing here. So nothing happening on the stack, no operation performed on the stack. Always remember, how do you know what operation performed? You need to focus like this. Epsilon slash epsilon, epsilon slash A slash epsilon, and this will give you the meaning. First one, nothing happened. Second one, A is pushed, and the third one, A is popped. So everybody has a meaning here. So what is there before, what is there after, that makes you the sense what is happened on the stack. Okay, if anybody written like this, A Z slash Z, it means two A's popped. Earlier double A Z is there, now Z is there, it means double A is popped, deleted from the stack. So this is how you should understand what is there before and what is there after. Anyhow, just focus on what is that second and third parameter. Now what is the third transition you have here? B comma A slash epsilon. What is the meaning of this? You are reading input B and top of the stack is A, top of the stack is A. At this time only, at this time you are going to pop A, you are going to pop A. How do you know that? Because A is there before, now nobody is there, that means A is deleted. So this transition is for pop A for input B. You can read that way, pop A for input B, and do nothing but change the state. And here whatever A is there, you are reading A and you are pushing the A without looking at the stack, just you are throwing it simply. Okay, this can help two things, whether the Z0 is there or A is there at the top, it can push, because here B's never comes on the stack, only A's we have pushed all the time. Now last one, this epsilon represent, it's not coming in the middle of the input, because if it comes in the middle of the input and from here there are no transitions. So this is specially designed for understanding the end of the input. Remember that this epsilon can come anywhere in the middle, but this epsilon is never comes in the middle. Why? If it comes in the middle, from here there is no transition to understand the remaining input. So this is designed specially for understanding the end of the input. So this makes, and at the end, that how do you know this is end or not? That depends on, it's just there before final, and from here there is no such things, right? B comma Z0 slash Z0. If you have that, oh, this you cannot assume as end if that is there. And we know clearly there is nothing is there after that. It means this is the only one option we have. It must be end of the input. So this represent end of input. But this not going to represent end. Whether it is end or not, that is decided by the input. If my input is epsilon, then I can assume two epsilons, the first epsilon and second epsilon I can go there. Okay, so understand this epsilon represent end, this epsilon we do not assume at end, because after that there are so many transitions left. Okay, at the end of the input and top of the stack should be Z0 and keep the same and go to final. So when will happen that Z0? Here you push A's, here you push the A's and you change the state and you will pop the A's for the B's. And when will that Z0 happen? Anybody can guess? Understand the three things in a sequence. Push the A's, let's say 100 A's you have pushed and you change the state, and 100 A's you have to pop to see the Z0, otherwise you will never see the Z0. If you want to pop the 100 A's, then how many B's should come? 100 B's should come, then only 100 A's will be popped. Then what is the meaning of this? To go to the final state, and what is the string pattern that happens in the language? Anybody? Okay, see that how much effort you have to take to understand. Never assume the PDA is easy. PDA will become easy when you practice, when you understand, and when you are able to understand every transition of the PDA, then it will become so easy. Okay, do not just read like A star B star, never do that way. It's A power n B power n. So epsilon it will accept or not? How? See that epsilon, epsilon, but keep the stack here. Oh, Z0 is there, I'm not looking here, Z0 only there, I'm going it. So here this epsilon is actually two epsilons, epsilon followed by epsilon, that makes you go to the final. Okay, next AB, how it accepts AB? First A you push, and then it's not just AB, AB is you need to understand this way, AB is actually A epsilon B epsilon. So this A you will push, Z0 is there, but without looking you are pushing A, and this epsilon you change the state, and this B you will pop A, and this epsilon you will go to the final. So this AB is actually A epsilon B epsilon, then you can go A epsilon B epsilon. So first A you will push and you will change the state, and B you will pop the A, then epsilon you will go to the final. Okay, similarly you can accept double A double B. So double A double B, how will you accept? Double A you push, then epsilon change the state, and double B you will pop the A, and then only you will see the Z0. This Z0 you will see only when the B's and A's are equal, otherwise impossible to see the Z0, right? Either you will see early or you will not see Z0. Okay, that means the strings are going to come in the pattern A power n B power n such that n greater than or equal to 0. So this is the language accepted by this PDA. So in the next session we are going to start designing PDA, and for every language we will understand how to design a PDA. Okay, so let me ask some questions here. Let me ask some questions, whether you have understood or not I will get to know. Okay, I'm just writing here. Okay, I don't know whether it's PDA or DPDA transition, just assume PDA. So what is the meaning of? Okay, so now you need to read. Okay, I'm just writing here. You are reading input X, okay, and top of the stack is, let's say, Y, and perform push X. So here one of them will be your answer. Just you need to find out which one is delta. Okay, don't worry about the states. Okay, I did not ask about it. Q comma X Y is equal to Q dash Y. Look at them carefully, which one is the right answer? X comma Y, Q dash comma epsilon, Q comma X comma Y, Q dash comma X Y, and Q comma X comma Y dot any. So any, basically you can write with any Z or any symbol, that's fine. Q dash comma X Y, that's dot any. Could be, this is MSQ type. Okay, I'm just giving a hint, it is MSQ. So more than one option could be correct. More than one option could be correct here. Fine. So similarly, I am going to ask the question, so answer it properly. Read X and no operation on the stack. So many things could be there, you need to identify all of them. No operation performed on the stack. How many ways you can do that? No operation performed on stack. If you want to do this in PDA, how will you do it? Let's see that. Q comma, you are reading X, I am just writing here epsilon, and Q dash comma epsilon. Q comma X comma any is equal to Q dash comma any. Delta Q comma X, let's say something, Z is not mentioned, means anything basically. Okay. Delta Q comma X, no operation performed, so let me write this as a capital X is equal to Q dash comma capital X. Here capital X, Z or anything basically. So this is also MSQ type, you need to identify which one is correct. It is possible that maybe all options are correct. I am giving hint, it is possible that all options could be correct. So you need to understand only the one thing, that remember that you need to understand what is here and what is here. If these two are same, then nothing happened on the stack. Whatever is written here, if you see there same, that means nothing is happened on the stack. You see that same, right? You see that same, right? Nothing happened on the stack. That means how do you understand? Before, after you see the same thing, that means nothing happened on the stack. It's going to be the all options. Come on, Raviteja. It's going to be the all correct here. There are multiple ways to understand the problem. Okay, it's all says the same meaning, any. Okay, sometimes you write epsilon, sometimes you write any, sometimes you write Z, sometimes you write X, and I did not mention what is X and Z. That means it is anything basically. Okay, I'm also giving the answer because you might be facing difficulty while answering it. Okay, question 3. Okay, what is the meaning of this motion? Okay, very simple motion I am giving here. A comma epsilon slash epsilon. What is the language represented by this? Okay, let's say M is here motion, and what is L of M? Use final state mechanism only, because that is only the primary target to understand. What is L of M? Is it just epsilon, or is it only A comma epsilon, or is it A star, or is it A plus? Okay. Question 3, very easy. Question 4, again M is given here, A comma A slash, let me take final here, A, and initially Z naught is there. Initially assume that Z naught is present on the stack, but nobody is there, only Z naught is there. And what is L of M? And that transition you need to know what is the meaning of it. Okay, so is it epsilon, or is it only A, or is it epsilon comma A, or is it A star? Okay, and then question 4 especially I am saying it's going to be the only option A. Why? It can't accept even single A. Yes, correct Raviteja, you're good. Because if you want to read A, already A should be there, but nobody is pushing A before reading A. That's why you can't accept any input except epsilon. Okay, I'm just giving the hint. And look at this one, question 5. M is given here as epsilon comma Z naught. You are going to push A and you are able to read A now. Oh, this makes sense. And let's say this is a final state. Now what is, initially Z naught is there, same. What is language represented by M? Now this time the answer is going to be, let's say, it may be epsilon, or maybe A, or maybe epsilon comma A, or maybe A star. So this time epsilon you can accept. If you want to accept one A, here you need to look at first epsilon. Oh, I forgot one thing to write, I am very sorry, that is A Z naught. I want to push A there, okay. You can't replace, that is invalid transition. Z naught slash A is never be there. Z naught slash A Z naught means A is pushed. When the Z naught is there, when nobody is there and you are reading, before reading, let's say I have an input double A, then here epsilon you can assume you can push A without reading anything. And when A comma A is there, you can keep same. A comma A you can keep them, keep same, but you can always halt at final. So this is a very interesting point. The question 5, the answer goes to the last option, okay. So anyway, it's a homework question to practice yourself, but why option D is the correct, that is your job. How do you understand, okay. So for today's, we have focused on what is PDA, but there is much job left, how to construct the PDA, and we know what is PDA, and we know how many parameters are there, we know how to use a stack and how to write the transitions. But in the next class we'll be having how to construct the PDA, okay. That's a more important one, but before that, focus on first how to understand each transition. That is already a big task for us, okay. Yeah, thank you so much, and Seema, Tanuja and all, okay, bye bye.